Now we're going to discuss episodic memory. And as we covered early in the course, episodic memory is the ability to recall many different events from the past, describing the people and the objects that were present, the interactions between the people and the objects, our personal feelings at the time of the event, and so forth, and not confusing different events together. These types of memories are generally fairly accurate, but errors certainly occur, perhaps less so for the general circumstances of the event, more so for sensory details. The degree to which we remember an event can depend on our emotional state at the time. As we discussed in an earlier lecture, there's this phenomenon called flashbulb memory, where if an event is dramatic, novel, and emotional, like the assassination of a major political figure, for example, later we can recall lots of details about where we were and what we were doing when we first heard news of the event. In fact, for any event in which strong emotions involved, like witnessing a violent crime, for example, we tend to be able to recall more about the general circumstances in which the event took place than for less emotional events. However, the more sensory memory, the appearance of different objects and so forth, is generally no stronger than for regular events. And there's also the phenomenon of post-traumatic stress disorder, where if someone's had a traumatic experience, in war for example, the experience is constantly recalled, along with the emotions at the time, to an incapacitating degree. Then there's a number of phenomena that are closely related to episodic memory. We can place events in a temporal order. We generally know whether one event happened before or after another, and we can work out whether two experiences overlapped in time, like remembering where we were living at the time some other event occurred. And we can tell how much time's passed during some experience. We can estimate how long we've been waiting, for example, even if we don't have a clock. Although those estimates can be somewhat unreliable. For example, if we're bored, our estimate of how long we've been waiting tends to be longer. Finally, we can also imagine events that never happened, and later recall those imaginary events. And usually we can distinguish between memories of real and memories of imaginary events. But in pathological conditions, sometimes imaginary memories can be created that we believe are real. So what we want to do is understand all these phenomena in terms of anatomy and physiology, as we did earlier for semantic memory. However, we're going to delay detailed discussion of the recall of personal feelings and emotions until we get to consciousness and self-awareness later in the course. Episodic memory retrievals are dependent on a critical type of information process. This process is activation of inactive cortical receptive fields, not on the basis that they're present in current sensory inputs, but on the basis that they changed or expanded in the past at the same time as receptive fields that are currently being detected. To see how this works, we'll start with a simplified high-level model of three cortical areas, each made up of an array of columns. Columns in that top area have receptive fields that can discriminate between different types of visual objects. The second area gets inputs from the top area and detects receptive fields that can discriminate between different types of groups of objects. And the bottom area can discriminate between different groups of groups. So let's imagine this brain is experiencing a novel situation, say meeting two friends, Graham and Mark, in a pub in Chelsea. There are a number of objects present, and populations of receptive fields detected within several objects are simultaneously kept active by the attention mechanisms we described earlier on. Crosstalk between the objects is avoided in the usual way by using different phases of frequency modulation, as I've indicated by the different shades of red. Most of the different types of visual objects have been seen before, so very little receptive field expansion is needed to reach the required minimum number of detections in each of the populations in the area. But then, outputs from the top area that indicate detections within the several objects separately are brought into the same phase of frequency modulation in the input layer to the groups of objects area, which effectively means they're released to that area, which in turn means they drive receptive field detections in that area. Now, although the individual objects are familiar, their arrangement in groups could well be a bit more novel, so the number of detections in this area is a bit low, less than the required minimum. So receptive field expansions are needed to bring the number of detections up, and I've indicated expansions by the somewhat darker shading towards the bottom of the columns. Then in the course of the experience, activity of the receptive field detections at the discriminates objects level is extinguished, but activity in the discriminates groups of objects area is prolonged, and attention is directed to several other objects in turn, generating 3 new populations in the discriminates objects area, again at different phases of frequency modulation. Once again, the outputs of the 3 populations are synchronized in the input layer of the groups of objects area, effectively releasing them to that area, where they drive receptive field detections, but at a different modulation phase from the receptive field detections within the first group of objects that have been prolonged. And once again, at the discriminates objects level, there was relatively little novelty, so little receptive field expansion, but once you get to the groups of objects level, the number of detections is below the minimum because there's more novelty and receptive field expansions occur. Activity in the discriminates objects area is extinguished once more, but activity of the 2 populations corresponding with the 2 groups is prolonged. Then the outputs from those 2 populations are released to the next area where receptive fields that can discriminate between different groups of groups are detected. And again, the arrangement of groups of objects into groups of groups is likely to be even more novel. So the number of receptive fields detected at this level is even more below the minimum required. And there has to be quite a lot of receptive field expansion to bring the number of detections up to the minimum. So, if we look at the pattern of activation at the groups of objects and groups of groups levels, there's been a significant amount of receptive field expansion. So let me keep a copy of the activity in the groups of groups area down at the bottom. Then think about what happens if we try to recall the experience later. Perhaps we hear words like, "What happened when you met Graham and Mark at the pub in Chelsea?" In response to hearing the words Graham and Mark, auditory columns are activated, which in turn indirectly activates columns at the discriminates between objects level via the semantic memory mechanism discussed earlier. The outputs from the indirect activations are released to the next array, where they result in receptive field detections corresponding with a group made up of Graham and Mark. Activity at the objects level is extinguished, and activity at the groups level is prolonged. Then the words pub and Chelsea are heard, and populations of receptive fields in the discriminates objects area are again activated indirectly in response to hearing the words. The outputs of these populations are synchronized and released to the discriminates groups area, driving a second population of receptive fields in that area. So now there's 2 populations corresponding with a Graham and Mark group and a pub and Chelsea group. Perhaps outputs from these 2 populations are synchronized in the input layer to the group of groups area, where they drive a population of receptive field detections at the group of groups level. But the overlap between that new group of groups population and the population active during the original experience won't generally be all that big. Maybe Graham and Mark have been often seen in other places, and different pubs in Chelsea often visited with other people. So there's no reason for there to be a strong correspondence with the population on the one occasion. So this isn't going to be a re-experience of the event. But now let's go back to the group of groups activated in response to hearing the words Graham and Mark. If again the activity at the object's level is extinguished, and activity at the group's level is prolonged, the active columns in this population have lots of different recommendation strengths. So suppose instead of combining immediately with the population corresponding with the pub and Chelsea, recommendation strengths of the type activate other columns on the basis of past temporally correlated condition recording are favoured. Each active column in the group of objects area will have recommendation strengths in favour of that kind of indirect activation for a number of other columns in the array. So for the one active column on the left, for example, let's suppose it has recommendation strength X in favour of indirect activation on that basis for each of the indicated columns. Each active column will recommend activation of a different group of other columns. Some columns will be recommended for activation by several of the currently active columns, so when the recommendation strengths in favour of activation of individual columns are totaled, one set of columns is recommended by quite a lot of the currently active columns. This set includes some that are already active and some currently inactive columns, and doesn't include some others of the currently active columns. So acceptance of these recommendation strengths means that the pattern of activation changes. This pattern of activation will tend to include columns that expanded when Graham and Mark were seen together in the past. And let's suppose the activity of this population is prolonged, and the population of receptive fields activated indirectly on the basis of frequent past simultaneous activity in response to hearing the words pub and Chelsea, and once again the outputs from these two populations drive a second population in the discriminates groups level, and again at a different phase of frequency modulation from that existing population. And this second population is also prolonged, and the same process of indirect activation on the basis of past simultaneous receptive field expansion is performed. And that results in a secondary population, and this second population will tend to contain a relatively high proportion of receptive fields that expanded in the past during experiences featuring pubs and Chelsea. The output from these populations are then released to the next layer, where they drive detections of receptive fields at the discriminates groups of groups level. The same process of indirect activation on the basis of simultaneous past receptive field expansion occurs. And that results in a population that includes a high proportion of receptive fields that expanded in the past during experiences that included both Graham and Mark and pubs and Chelsea. There could also be recommendation strengths in favour of indirect activation on the basis of past simultaneous expansion between areas, in both directions, from the more complex to the simpler area and from the simpler to the more complex area. And this could further push towards a final population with a lot of internal consistency on the basis of past simultaneous expansion. Now, because there was a high degree of receptive field expansion at the time of the original experience, if the seed words are well chosen, there'll be a fair amount of overlap between the indirectly activated population at the end of this type of process and the population that was active at the time of the earlier experience, especially at the more complex receptive field levels. And this indirectly activated population will be experienced as a kind of re-experience of the earlier event. But as for semantic memory, without receptive field activations close to sensory inputs, so once again it won't be a visual hallucination. So indirect activation on the basis of past simultaneous receptive field expansion provides the information basis for retrieving episodic memories of unique events, with retrievals being easier if the degree of novelty in the original experience is greater. The indirectly activated receptive fields will have recommendation strengths in favour, for example, of verbally describing the experience, including many aspects of the situation that weren't present in just the seed words. One other aspect of episodic memory at this simple model level. If an active column has recommendation strengths in favour of indirect activation of other columns that expanded their receptive fields in the past, not just when the column itself expanded, but recommending columns that expanded a little later than it expanded itself, then an active population of columns corresponding with the population at one point during an earlier event can indirectly activate a population corresponding with a slightly later point. In other words, the subjective experience of moving through a sequence of past experiences can be created, which is indeed the experience we have of episodic memories.